Hello again, guys. It's Mr. Munyon here with activity 11-2 on triangle congruence criteria. So let's go ahead and jump right in, get started. Okay, our goals for today are to develop criteria, figure out what we need to know to prove that triangles are congruent, and then use that criteria to help us determine congruence, what triangles are congruent. So determine congruence criteria so that we can identify two triangles are congruent. So hopefully we know that congruent means all sides and all angles are congruent. All corresponding sides and angles are congruent. However, to prove that two triangles are congruent, you don't actually have to look at all six sides, all six parts, all three sides and all three angles to identify whether or not they're congruent. Maybe I could just look at the sides and not have to know anything about the angles, prove the triangles are congruent, and then I would know for sure that the angles have to be congruent as well. Maybe I could just look at a couple of sides and a couple of angles, prove it's congruent, and then I would know the third side and the third angle have to be congruent. So our goal is to figure out exactly how much information we need to prove that triangles are congruent. And obviously I mentioned it's not all six pieces. You don't have to look at all three sides and all three angles. So Greg wants to figure out how much information in this problem. If you want to read the first part, Greg's helping us on his construction job. But first one, he's only going to check one pair of corresponding parts. That one seems obvious to me. If you have one angle, let's say 30 degrees, that's obviously not going to be enough to prove congruence, because I could have a triangle that looks like this with a 30-degree angle, or a triangle that looks much different. So one angle is not going to be enough to prove congruency. Same thing with a side. You could have a 3-4-5 triangle or a 5-12-13 triangle. Just because I have one side that's the same doesn't mean, let's say I'm looking at the side that's 5 or a 5-12-13. Definitely not enough information to prove congruency. So in class, this would be done with like a hands-on activity where people are actually checking. We can pretty much skip this first one, actually even looking at any more examples, because I know one piece of information is definitely not enough. Whether it's one side or one angle, definitely not enough information. So ultimately, there's not enough information. All right, so from here, we can check two things. So on the next page here, Greg wants to start by looking at two pieces of information. So draw a triangle. Let's start at the top. Greg wonders if checking two pairs. Greg starts by considering the triangle below. Draw triangles that each have one side congruent to AB and another side congruent to AC. So let's pretend we measure these here. Let's say this is 5 and this is 9. Now, most of you guys could very easily draw some other triangles that have sides of 5 and 9 that don't look like this. Maybe I could draw a triangle that looks like this. 5, 9, and then however far I need to get to right here. So that was really ugly. Let's draw it a little bit different. Could look like this, could look and who even knows what this other piece is, but it doesn't look anything close to that. Look at this angle in between there. That's an obtuse angle. This is an acute angle over here. Nowhere close. So I already know two pieces of information is not enough. If I were to check two angles, well, I could even know all three angles. If I know two angles, you could actually solve for the third angle using the triangle sum theorem. So let's say I have two triangles that, let's keep an easy one here. Let's just use like a 30, 60, 90. But if I don't know any of the sides, I could draw a similar triangle that has the exact same angles that's way bigger, so it's not going to be congruent. It would be similar if I knew two angles, like if this was 60 and this was 90, not drawn to scale. Using the triangle sum theorem, this would have to be 30. But if you don't know anything about the sides, not going to help you prove congruency because we don't know how big either one of the triangles are. So saving a little bit of time, blah, blah, blah. We know that 2 pieces of information is not enough. Whoops. Okay, so when we get to the next page and we start investigating 3 pieces, we're going to start using abbreviations S for sides and A for angles because we could have lots of different combinations. Looks like we have 1, 2, 3, 4, 5, 6 different possible combinations. And notice right here between like the first and second one, they have it listed differently as side, angle, side, compared to the next one, side, side, angle. Because having an angle in between 2 sides, whoops, I probably shouldn't put 2, let's put 3 on that one. Having an angle included in between 2 sides is different than if we were to have 2 sides and then, whoops, and then an angle, you know, identifying this angle right here. So those are 2 different things to check. If there's an angle included in between 2 sides, or if there is an angle at the end of 2 sides. 2 different things to check. So just because you have 3 pieces, the order of those pieces matters. So let's go ahead and mark the order of these pieces of information that are listed. We have side, angle, side. This one is side, angle, side right here, already labeled for us. Let's make this next one side, side, angle. So let's mark a side, and then an angle. The next one is angle, side, angle. So angle, side, angle. We could mark an angle, and then the next side, then the next angle. Angle, angle, side. Same thing. Having the side included in between these angles right here is going to be different than having an angle, and then the next side. So see how we're actually like going in order around the triangle. We're like connecting the pieces to the next piece it says. This side right here is touching this angle, is touching this side. So like here we have a side, it's touching this angle, it's going in order to the next side. Right here, this side is touching that side, is touching that angle. So from this side to this side, it's touching the next angle in order. We don't go backwards. We don't say side, side, and then go backwards angle. We go the same order, whether it's clockwise or counterclockwise around. So let's see if you guys can try these last 2. Take a moment, see what you got. Actually, they're both super easy, never mind. So side, 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 and angle, angle, angle. All right. So hopefully you guys understand here, because this is actually a point of confusion for some people, is making sure you recognize that the order matters and how exactly you're able to label and look when you're comparing triangles that you're trying to see if they're congruent. So most important thing about this, we're using the abbreviations S for side, A for angles, and the order of these matters. And the easiest way is if you have a side or an angle included in between 2 other pieces, it literally has to be in between those pieces when labeled on your figures. So this angle has to be included in between those 2 sides. Here, this side has to be included in between the 2 angles. So the side is literally in between the 2 angles. Are there any other combinations of 3 parts of a triangle? If so, it is necessary for Greg. So you may think like, oh, what about angle, side, side? I don't see that listed. Well, technically that's this same piece backwards though. So yeah, there are combinations of backwards ones like side, angle, angle, and angle, side, side. Those are ones that we could have done as well, but it's the same thing forwards and backwards. So side, angle, angle, and angle, side, side are ones that we could use, but it's the same as forward and backwards, just backward versions of other ones. All right. So you can probably guess that we are going into much more detail here because 3 pieces of information is probably going to be able to prove congruency. Maybe all of these cases will work, and maybe not all of them will work. Maybe none of them work, but we get close. In any case, we obviously need to explore this much further. So let's go ahead. Whoops. Let's go ahead and start exploring these possible combinations. All right, so let's find out which pairs of corresponding parts work. 3 segments, congruent sides shown below. We need to use some manipulatives here. We aren't going to be able to do all of the hands-on stuff that we have here. So what we are going to do is we're going to make a list of stuff that definitely does work and talk about some that do not work in this case. So 3 pieces of information is the key. However, some of the combinations do work and some of the combinations don't work. So let's go ahead and start a list over here. So let's start with side, side, side. All right, let's start with one that you're probably familiar with from Pythagorean theorem, or maybe with, I even watched this in Mr. Lindsay's live class. He was talking about Pythagorean triples, a 3, 4, 5. So 3, 4, 5. Is every triangle that has sides of 3, 4, 5 going to be the exact same triangle? So if I drew a different one, let's say I drew a 3, 4, 5. These are right triangles. I guess I could label that. Is it going to be the exact same triangles? Yes, obviously the sides are the same. But if I changed one of these angles, like let's say I tried to make this a bigger angle, that would change one of the sides. So the angles are going to be stuck where they're at as well. Which means no matter how you rotate or reflect, if we just learned about translations, you could reflect this into any other 3, 4, 5 triangle. The angles aren't going to change. So this one does work for proving congruency. We're just going to use this table. We're not going to name the triangles from the activity. We're just going to put the combination and whether it works or not. And over here on the side, I'd actually like you guys, if you're doing some notes, to focus more on the ones that don't work. So I'm just giving some examples here, but you definitely need some examples of the ones that don't work. So let's go to side, angle, side. All right, this one would be like if I had a side here, let's just pick a number 7, an angle of, let's say, 20 degrees, and let's say this side is 8. All right, so this piece is stuck here. This angle isn't going to open or close. This piece is stuck. I don't know this distance right here, and I don't know these angles, but can any of these pieces move and make another triangle right here? Could this get longer and make a different triangle? No, you couldn't do that. Same thing, 8 can't get longer, and the angle can't get bigger. So this one actually also works for proving congruency. All right, let's go to, let's do angle, side, angle, the one where the side's included. So let's just make up an angle here. Actually, let's put a side in the middle here. Let's say this is 10. And let's say I'm going to make up an angle here. Because I don't know this side, I'm putting it as a dotted line. And let's say this is about 40 degrees. So same thing on another triangle. I do know that I have a side of 10 and an angle of 40. No, that's not that good. I should probably redone that one. There we go. Over here, let's say I have an angle of 10. So let's make this much smaller. And I have an angle of 10. So here I have a side and an angle. I don't know this side, but I have this angle over here, 40, same thing on the other one. What do you guys notice about these? Well, at this angle, it's going to end up making the exact same triangle right here. on both of these because given that angle, they're going to intersect at the same spot, even if I have no idea how long these pieces are right here. So this one actually also works for proving congruency. So right now we're 3 for 3. Great. Let's try another one here that we see a lot. Angle, angle, angle. We actually already talked about this at the beginning. You could have similar triangles that have all the same angles, but aren't the same size. So that isn't enough to prove congruency. You definitely need at least one side because otherwise you just know for sure that they might be similar but not congruent. So even without labeling the angles, let's just say all the corresponding angles are, 50, 50, and 80, whatever we got here. It doesn't matter. But this is not enough information because we could just prove they're similar. Even if it had all three the same angles, they would just be similar, not necessarily congruent. They could be congruent, but we couldn't prove it using just angles. All right, let's go angle, angle, side. All right, so let's do an example of the angle, angle one. I mentioned you'd probably need an example there. I would definitely recommend you draw a couple of different sized triangles that are similar and identify the angle, angle, angle does not work. All right, for angle, angle, side, let's pick up some angles and a side and see what happens. So let's say I have a side. Let's start with a side here. Right, and give me an angle. Let's say 80 degrees. All right, whoops, I should probably have done that one dotted because I don't know the side. So let's say this is 2, 3, 4, 5 right here. I've got a nice 80-degree angle right here. So let's pick a different one. 1, 2, 3, 4, 5, and I have like an 80-degree angle right here. Okay, and let's say I have another angle. So doesn't matter where I pick this angle right here, but wherever I put it, it's got to connect down here to make a triangle, right? So let's say I pick up here, even though I don't know this side. Wherever I pick that point up there, that's going to determine the angle and actually also determine how long this other side has to be. So if this is up 1, 2, 3, 4, 5, 6, and over 1.5. Let's say I go over 1, 2, 3, 4, 5, 6, over 1.5. That's in the exact same spot as I did up here. When I connect those dots, it's going to actually end up making the exact same triangles for both of these as well. Angle, angle, side does work for proving congruency. All right, last one is angle, side, side. All right, and this one actually does not work because I'm going to draw you the examples that don't work right here. All right, so here I drew two separate triangles, not drawn to scale, not perfect, but here notice I have an angle and then a side on the top triangle here. On the bottom triangle I have pretty close to drawing the same angle and then a side of looks about like 7 and a side of 5. And these are not the same because this piece right here technically could swing from here all the way to here and make two different triangles. So there's one triangle that looks like this one, and then there's a separate triangle that I could draw with the same angle, side, side, that looks completely different. And if this piece right here isn't being defined by a specific angle, maybe the 5 goes this way and we get this obtuse angle here. We get this triangle. Maybe the 5 goes this way and we get this smaller. It could be obtuse. I don't know about this angle right here, but we get a a different shaped triangle. So this one does not work for proving congruency. Not enough info to prove congruency, or you can put nope. And once again, it is important, I would say, you try and draw these two examples to show that angle side-side does not work, because you could very easily have a swinging piece kind of, and there's two specific triangles that you could end up with angle side-side. So we don't necessarily know that everything about them would be congruent. All right, so at this point, you'll notice we have 1, 2, 3, 4, 5, 6 combinations up here, and some of them do work and some of them don't work, and you're probably like, Mister, this is a bunch of random combinations of S's and A's. How am I supposed to remember all the ones that work? It's actually easier to remember the ones that don't work. So yeah, all the other possible combinations that we came up with that work forward and backwards, instead of trying to remember all of those, you know, eventually with enough practice, you'll probably be able to do it. But it's easier to remember the ones that don't work. AAA, AAA, or batteries, and ASS, donkeys. So batteries and donkeys. You can, next time you go to school, you can run down the hallway chanting, well, don't say that, but you can do it in the name of geometry now, and you won't get in trouble. Just tell your teacher you learned about angle side-side. Doesn't work for proving congruency in triangles, and they'll just be confused and you can walk off. All right, so those are the two that don't work: donkeys and batteries. AAA batteries and our euphemism, not a euphemism, another way of saying donkeys. All right, compare your results, blah, 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 blah. We're not going to compare with our neighbors because we didn't. Do we think those work? We've already summarized the activity that we were supposed to do there. So let's now look at some practice problems. For each pair of triangles, determine which triangle congruency criteria will work for proving congruency. So looking at these two triangles, I see that there are 3 pieces of information. Great. Let's check what they are and the order. So this is side, side, and side. I think this one's pretty obvious for you guys. This one is also side, side, side. So this is one of the ones that work because this is not donkey or battery. So obviously this is what we're using to prove that we know these two triangles are congruent. On the next one, we look at this one and we say, oh, there's only 2 pieces of information. But you'll notice, like, it does say angle, side, angle. Where exactly is the third one? Well, we notice they're touching here. Sometimes there are some additional pieces of information that we could label, like vertical angles are an angle pair that we learned about that we know are always congruent. So if I label these vertical angles, I now have 3 pieces of information on each one. Here I have an angle with an included side, and then another angle. That is the exact same information I have on the other triangle in the same order. Angle with 1 arc mark, included side, angle with 2 arc marks. So I can use these to prove these two triangles are congruent by angle, side, angle. Remember, this one does work. The only ones that don't work are donkeys and batteries. All right, so let's try a couple now. This is a good spot for this video. Let's try a couple now. For each pair, write the triangle congruence criteria, if any, that can be used to show the triangles are congruent. So at initial glance, A, you're like, definitely not enough information. There's only one thing marked on each of these two triangles. However, there are shared sides. So I don't know the length of that side in the middle, but whatever it is, I know that both of these are going to be congruent length. So I do have 2 pieces of information now. Do you see any angles that I could label? Well, it looks like there's a lot of pieces that I could, that look congruent. You may say to yourself, like, hey, mister, these look congruent right here. Can I just label the, whoop, not that one. Like this one, can I just label that? No, because there's no reason why you could label that. You would have to have a reason why you could label it. So on that problem up here, why did I label these congruent? The reason was they were vertical angles. Why did I label this congruent? That's called the reflexive property of congruence. When there's one piece on two different triangles, it's going to be the same length. But there's not a reason. I'm going to go to the next one and then come back to this and talk about why there's not anything else we could label. So for right now, there's not enough info. All right, so for part B, I do see that there are these marks here, the tick marks that indicate they're congruent. So each of these triangles has at least one piece. They have the shared sides in the middle that we talked about, but they also have these other extra arrowheads here in the middle. And remember that that means that they are parallel to each other. So it actually looks as though I have parallel lines cut by a transversal right here. So I have these parallel lines cut by this transversal, and I learned that there were some angle pair relationships between the intersections on the transversal. So remember those like corresponding alternate interior, alternate exterior? There are some alternate interior angles here that I can label on the parallel lines cut by the transversal. Notice this is on one side of the transversal on the interior of the line, and I go to the other side on the interior. There is another angle down here. These are alternate interior angles. So I can label that one. So I'll make it a little bit neater here just so we don't have all the extra lines. We have 1, 2 pieces, 3 pieces on each triangle. Now we need to determine the order, see if it's one that works. So on the bottom triangle, it looks like I have a side, and then an included angle, and then a side. Same thing, side, angle, side. I guess, you put it right there. So side, angle, side. Is that one that works for proving congruency? Yes. So side, angle, side congruency. So this one, I did have enough information. The reason I labeled these was not because they looked congruent. It was because they were alternate interior angles on parallel lines cut by a transversal. These, everything about these looks congruent. You're like, but mister, they're congruent. You can only prove they're congruent if you have information that says you have the right pieces in the right order to prove congruency. So you may be like, mister, I just know it, they're congruent. That's not what we're doing here. We're trying to look and see if we have enough information that's either already labeled or that we know for sure based on a definition or a postulate, or a theorem that says they are definitely the right pieces of information in the right order to prove congruency. All right, let's go ahead and jump down to check your understanding. Pause here, work on questions 8, 9, and 10. When you feel like you've got an answer or you got stuck, go ahead and restart the video. All right, so let's go ahead and go over these. 2 triangles, each have 2 sides that are 8 feet long and an included angle of 50. Must the 2 triangles be congruent? So each 2 triangles have 2 sides that are 8 feet long and an included angle. So 8, 8, whoops, and 50 degrees. 8, 8, 50 degrees. Probably not drawn to scale. But is this the right information in the right order to prove congruency? I purposely drew these not very great just to look at the information. I have a side, corresponds to a side. I have an angle that corresponds to an angle, included angle, and then another side, another side. This is side, angle, side. Does this work for proving congruency? Are these 2 triangles congruent? Yes, by side, angle, side congruency. All right. 2 equilateral triangles each have a side that is 5 centimeters long. Is it possible to conclude whether or not the triangles are congruent? So what does equilateral mean? The equilateral literally means equal sides. So you have 2 triangles that are equal, all have equal sides. So this other one, so this is It doesn't tell us specifically for the first part that, the two things are equal, but I know there's one equilateral triangle here, one equilateral triangle here. Hopefully you know that there's actually a couple of different ways to do this one. If you know that all equilateral triangles are also equiangular, that's one way to do this. All the angles are 60. That way you could actually use angle, side, angle to prove congruency on this one. But because if they both have a side that's 5, that means all of these sides are 5. And if this side is 5 over here, all of these are 5, which actually means both of these triangles have to have, I've got 5s that look like S's already anyways. This is side, side, side congruency that you can use. That'd probably be the easiest way. If you happen to go ahead and label the angles are all 60 degrees, you could use side, angle, side, or angle, side, angle, or angle, angle, side. Any of those would work. You can't obviously use angle, 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 or angle, side, side. So the easiest way to do this one would be side, side, side congruency. The figure below shows a circle and two triangles. For both triangles, two vertices are points on the circle, and the other vertex is the center of the circle. What information would you need to know in order to prove the triangles are congruent? So, okay, looks like we have a couple of triangles here that each triangle goes from the center of the circle to, I'm going to zoom in just a little bit here, goes from the center of the circle to a point on the circle. So each leg of these, what looks to be kind of isosceles triangles, is actually a radius, and conveniently every radius is also going to be the exact same length. So I already know two pieces of information on each of these triangles. I would just need to know one more and make sure it was in the right order. One piece that you could do that would work would be the angle at the center on both of these. If that was congruent, then you could do side, angle, side, side, angle, side to prove congruency. Another way you could do this, so let's say we weren't using the angle right there, is if you knew the chord created, that the chord that's the base of these isosceles triangles. Oops, I guess that would be a different length, so 2 tick marks. You could use side, side, side. So if the chord that's the base of each of those triangles was congruent, or if the included angle in between the two legs of the isosceles triangles at the center of the circle was congruent. So either a vertex angle on the isosceles triangles or the base of the isosceles triangles being congruent would be enough to prove congruency. So I'm going to go ahead and write that out just so we have these in our notes and something that would make sense. So it could be this one and side, 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 or it could be this one. Obviously, you could add lots more information. You could put more angles and stuff in there. What you could not do, I guess we need this piece here. What you could not do is say one of the two base angles on the triangle. Like if I was to identify, whoops, that's not what I want to do. I wanted to switch colors there. Let's say I wanted to identify like this angle was congruent to this angle. Well, that would end up actually having angle side side if we didn't have the vertex angle in there as well. So that would be, if you added 2 or 3 pieces of information, obviously you could do that, but with only adding one piece, these are the only 2 ways you could do it. So and if the vertex angle at the center of the circle, that's another way. Side, angle, side would work on that one. Okay, same thing as before. Now we are ready to move on to the lesson practice section. So take a moment right here. How many questions we got? Just these? All right, so work on 11 through 15. The first 4 are relatively easy. Then we do want to talk about 15. So pause right here. When you're ready to go ahead and start the video back up and we'll go ahead and go over these. All right, let's check and see how you did. So the first section here is asking us to, for each pair, write the congruency criterion, if any, that can be used to show that these are congruent. So on this first one, 3 pieces of information. It looks like I have an angle here. And then the next piece is an angle and a side. So angle, angle, side. Notice the side I'm using is not included. So angle, angle, side. Angle with 2 arcs, angle with 1 arc, side. Angle with 2, I'm going to go ahead and put that. Angle with 2 arcs, angle with 1 arc, side. So I can use angle, angle, side. That is not donkeys or batteries, so that one does work for proving congruency. So yes, this one does work. Here I only have 2 pieces, so I need to look for a third. Things that we could look for to prove congruency would be, the most common ones are shared sides, vertical angles, parallel lines cut by a transversal. Outside of that, you could look for any definitions, like if it tells you, something's a midpoint, you might have 2 extra halves that you could label as congruent. If it tells you some angles are bisected, you could label that each half of the angle. But for the most part, shared sides, vertical angles, and if you have parallel lines, there's a good chance that you're going to be able to label something on there. All right, so we do have shared sides on this one, so that makes this one real easy. Side, 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 1, 2, 3 tick marks, side, side, side. So this one here, side, 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 does work for proving congruency. All right, on number 13, I see on each triangle, I have 1, 2, 1, 2. So I do need to look for something. I don't have any shared sides, but I do have vertical angles. So I can do that one. And looks like, very quickly, I do have angle with 1, side, angle with 2. Angle with 1, side, angle with 2. So angle, side, angle. And the reason I put these little subscripts down here is because the order of the angles that you're using, whether it has 1 or 2 tick marks, is actually important. Because if it's not the same order, sometimes, especially like on this one, if this was backwards, this would not work for number 11. All right. Here, we actually don't have any congruency markings on number 14. Those symbols, you can't mark them as congruent. A very common mistake would be like, oh, this side, and the shared side's in the middle. Obviously, we can label the shared sides, but those parallel markers do not indicate that those are congruent. So if you put side, side, side on this one, you would be incorrect because we actually don't know the lengths of these sides over here. However, because these are parallel lines cut by a transversal, I can label any relationships that are congruent on parallel lines. So corresponding, alternate interior, alternate exterior are all congruent. And if I look at this transversal here, there are some alternate interior angles that I can label on there. So I could go ahead and label these 2 alternate interior angles. I guess I could label the shared sides on there. So now I have 2 pieces. I do need another one. Luckily, the other parallel lines, big indicator. I need to look for parallel lines, transversal. Do you see another pair of alternate interior? Yep. Okay, great. So once I have those labeled on there, it looks like on the top triangle, I have an angle with 1 arc, a side, an angle with 2 arcs. The side was included in the middle. And on the bottom triangle, angle with 1 arc, included side, angle with 2 arcs. So angle, side, angle, does work for proving congruency on this one. Wow, conveniently, only one of those had 3 pieces, but using shared sides, vertical angles, parallel lines cut by a transversal, we literally used all 3 of those on 12, 13, and 14 to be able to add some stuff to the picture and prove that these triangles are congruent. You may have just said, yeah, they're congruent, but if you don't know the reason and you don't know what you can and can't label, obviously you're not going to be able to get these correct. All right. Last one here, what additional piece of information you need in order to conclude that these triangles are congruent? Is there more than one set of possible information? So right now, I do have a straight angle here with 190-degree angle. So they don't need to add this. We could tell that this has to be 90, has to add up to 180 there to be supplementary angles that add up to a linear pair. I know that I have a shared side in the middle. So I can go ahead and label that one. Looks like probably could do a couple of different ways on this one because I have one side and one angle right now. If I look for vertical angles, not on there. Don't see any parallel lines, not on there. Doesn't tell me any definitions. So there's definitely a couple. So one thing I could do would be like these angles up here. If I labeled these, I would have angle, side, angle on the left triangle, angle with one arc, side, 90-degree angle. So if angle ABD was congruent to angle CBD, you would have angle, side, angle. All right, let's say I didn't add that piece on there. So I still have, if this is 90, the other side definitely has to be 90. Shared sides are still there. I could say that these pieces here are congruent. So if AD was congruent to CD, I would have side, angle, side. So if segment AD was congruent to CD, I would have side, angle, side. Is there any more? Yeah, you could even do another one here. Would this work for angle, angle, side? So angle with one arc, right side. Over here, angle with one arc, side, angle with one arc, 90, and then side. So angle, angle, side. That's one that works for proving congruency as well. That's not batteries or donkeys, so that does work if angle A was congruent to angle C. Okay, from here, I do want to point out that if you only labeled these sides right here, there is actually something that we haven't talked about yet that we need to address right now. I don't know if it's done in the next lesson, so let's talk about it now just to make sure that you cover it. Right here, let's say I labeled these sides. You may say that this is side, side, angle. The angle is not included, so it's at the end. So side, side, angle, or backwards, angle, side, side. You're like, that does not work, sir. That's one of the two that I learned does not work. So angle, side, side does not work. However, the angle is a special angle because it's a 90-degree angle. This happens to be a right triangle right here. So if I was to label this side, what do I know about right triangles? Well, there's a Pythagorean theorem that says if you know two sides, that you are able to solve for the third side. And that third side is going to be whatever you get when you do a squared, well, I guess in this case, c squared minus a squared will get you b squared, the third side. So whatever you get for this side right here is going to be the exact same value over here. So whenever you actually have side-side angle, but the angle is a right angle, that one does work for proving congruency. And that's actually called RHL. Oops. And that stands for right hypotenuse leg. Sometimes it's just abbreviated as hypotenuse leg, because if you have a hypotenuse, that also means you have a right angle. So, but to leave it as 3 pieces, it's right hypotenuse leg. This one does work for proving congruency. So if AB was congruent to CB, you would have RHL. So not every time that you see angle side side, it doesn't work. If the angle happens to be a right angle, it does work. Obviously, we didn't have an example earlier, but figured I definitely need to address that now because I'm not sure if it's the next one. Hopefully you guys feel good with this lesson, because you're going to get more in depth and eventually get to some proofs with these triangle congruency. I have lots of practice with this, so if you still feel like you're struggling, you come to one of my tutorings and I'll make sure that you get some extra practice with these, because it's good practice. I also want to mention at this point, because this is something students generally struggle with, there's some good Khan Academy on triangle congruency. If you search for it on Khan Academy and can't find it, just send me a message on Remind or an email. You guys have access to my email, Kyle Munyon. I'll be happy to forward that Khan Academy to you as well. Good luck. Take care. See you guys next time.